So today, we're going to dive into what might be one of the most ambitious, maybe even craziest infrastructure projects in history. This is all about OpenAI's wild plan to get its hands on enough computing power to literally build the future of AI.
And it really all comes down to this one question. What does it actually take to power the next huge leap forward in artificial intelligence? Well, the answer starts with a number that's kind of hard to even process. Let's just start with this, $100 billion. And get this, that's the reported price tag for just one piece of this whole strategy, a huge partnership with NVIDIA. As you're about to see, that's really just the tip of the iceberg. But it's not just about the money, right? It's about power. We're talking raw electrical power. OpenAI has somehow locked in commitments for 26 gigawatts of AI compute. So what on earth does 26 gigawatts even mean? Okay, to put that number in perspective, 26 gigawatts is more electricity than some entire countries use. Let that sink in. We're not talking about building a few more data centers. This is like building an energy grid on a national scale, all just for AI. So yeah, this completely changes the conversation. This isn't just about business deals anymore. This is about building a totally new kind of global infrastructure. OpenAI isn't just buying computer chips. They believe they're laying the foundation for the entire economy of the future. And you can hear the stakes right from Sam Altman himself. When he says compute is the basis for the economy of the future, he's basically saying it's the 21st century's most vital resource. More important than oil, more fundamental than even electricity. And that's the core belief you have to justify a project on this unbelievable scale. So the big question is, how does a company even begin to acquire this much power? Well, it turns out you can't just go to one store and buy it all. OpenAI has this really complex three-part strategy, basically because their appetite for computing is so huge that no single company on Earth can feed it. All right, pillar number one, the big one, this massive alliance with NVIDIA. You got to think of this less like a simple shopping trip and more like a deep co-development project. It's a $100 billion deal where NVIDIA isn't just a seller, they're also an investor, and they're working hand in hand with OpenAI to design the hardware and software for tomorrow's AI, all built on their next-gen Vera Rubin platform. But you know what they say, putting all your eggs in one basket is a really bad idea. So the second part of their strategy is all about diversification. OpenAI is also teaming up with other huge players like Oracle and AMD. It's a smart move. It spreads out the risk, means they're not totally dependent on NVIDIA, and gives them access to a way bigger pool of hardware. And this is where the plan gets really wild. Because even buying chips from NVIDIA, Oracle, and AMD still isn't enough. So the third pillar, the ultimate power move, is to co-develop their very own custom AI chips from scratch with Broadcom. This gives them total control, maximum efficiency, hardware that's perfectly tailored to do exactly what they needed to do.
Just listen to this from OpenAI's president, Greg Brockman. He's talking about deploying 10 gigawatts just with NVIDIA. And when you stop and realize that that absolutely colossal project is only one piece of their whole plan, the true scale of what they're doing, it's mind-blowing. Okay, so this brings up a pretty obvious question, right? How in the world is a company that isn't even profitable yet paying for the biggest infrastructure project in AI history? Well, the answer is in this really fascinating, kind of circular financial loop. Let's just follow the money here because it's a wild ride. Step 1, a chipmaker, say NVIDIA, invests billions of dollars into OpenAI. Step 2, OpenAI turns right around and uses that exact same money to buy billions of dollars of chips from NVIDIA. Step 3, this makes NVIDIA's revenue numbers look incredible, which investors absolutely love. And step 4, both companies' valuations just skyrocket. It's this perfect self-fueling cycle where the investment literally creates its own demand. Now, you know what's incredible about this? This perfect description didn't come from some Wall Street analyst. It came from a commenter on the Tom's Hardware forum, the AI Mobius strip. It's just a brilliant way to describe this loop where money and value just feed each other in an endless circle. But this whole story is so much bigger than just one company's balance sheet. This frantic grab for computing power is a major move on a much larger global chessboard. The race for who controls semiconductors, well, that's the new arms race, especially between the US and China. And this whole competition is being fueled by an idea called techno-nationalism. It's basically the belief that a country's security, its economy, and its power on the world stage are all directly tied to who's winning in technology. And in the 21st century, controlling the chip supply chain is seen as the key to all of it. So what happens is you get this situation called weaponized interdependence. Imagine the global tech supply chain is one giant pipeline that every country needs to drink from. Well, if one country controls a crucial valve along that pipeline, like, say, chip design software or a specific manufacturing tool, they can threaten to turn off the tap. They can squeeze that choke point and turn a simple business dependency into a powerful geopolitical weapon. And this map just lays out that battlefield perfectly. No single country can do it all. The US is king of chip design. Taiwan absolutely dominates advanced manufacturing. The Netherlands has a total monopoly on the machines needed to make the best chips. Japan, South Korea, they all own critical pieces, and each one of those pieces is a potential point of leverage. So, faced with this scattered map and China's huge ambitions, the US knows it can't go it alone. It's actively building teams like the Chip4 Alliance with Taiwan, Japan, and South Korea. The goal is to get all the key players on the same side, lock down control of those critical supply chain choke points, and make sure they maintain their technological edge. So, look, the vision is absolutely massive, and the strategy is literally global. But we have to be honest here. This is a gamble of epic proportions. The road ahead for OpenAI is filled with just colossal risks and some really big question marks. And the hurdles are just enormous. You've got huge regulatory risk. Governments are definitely going to start asking questions about these deals. Then there's the logistical nightmare of actually finding 26 gigawatts of power. That means new power plants, new grids. There's huge financial risk, betting billions on a business that's still not proven it can make money. And maybe the biggest of all, execution risk. They're banking on custom chips that haven't even been built yet. And don't just take my word for it. NVIDIA's CEO Jensen Huang, a guy at the center of all this, he confirms the stakes. That's not an exaggeration. This is, by any measure, the biggest AI project ever even conceived. Which, of course, brings us to one final huge question. So, what are we looking at here? Is this a brilliant, visionary masterstroke that will secure the future of artificial intelligence? Or is it the biggest, most expensive bet ever made in the history of technology? A speculative bubble that could pop with spectacular results? Right now, nobody knows, and the whole world is watching to see what happens next.